really perfect that we're segueing into my talk. I was thinking through the last panel. My talk will weirdly kind of tie a lot of things up that we have questions about. So my name is Sharon Campbell. I'm from the Menzies Institute of Medical Research, which is part of the University of Tasmania. Shout out to some collaborators and co-authors, a couple of them are here, Amanda and Faye. Faye got me in the room. But also Terence Butler and Nigel Goodman from the University of Canberra and Nicholas Butcher-Harrod out of the Faye mentioned before, who has done a lot of economic modelling for us. So what I'm going to talk about is we're heading into the space of solutions now. So we've talked about fire, we've talked about smoke, but now we want to talk about reducing the impact of smoke on the people that are most vulnerable, most susceptible, our priority populations. And when we do that intervention, is it cost effective? So the reason that we got into this work in the first place, it was funded back in 2021 through an Asthma Australia Research Translation Grant. And the aim of the whole project was to synthesise, translate, disseminate the best available scientific evidence on the effectiveness of air pollution exposure reduction measures. That is a lot of words, isn't it? But basically what we're trying to do is we're trying to work out what works in the space of making people healthier in the face of smoke. And there was two papers that were published that sort of feed into this, and I'm doing a little bit of a love story of these two papers. So the first one was authored by Nigel, and he did a really thorough systematic review on interventions for reducing exposure to air pollution from landscape fires in a changing environment. Obviously, exposure to air pollution from landscape fires we could substitute in planned burns, we could substitute in wood heaters, anything that's a biomass burning event. And what we found in that systematic review was that there was really three types of exposures, and they're communicational and behavioural, so they're things like alerts and messages, apps that we've spoken about a bit. There's ventilation and filtration, which we've spoken about quite a lot, and then respiratory protective equipment. And these are all individual responses to reduce our personal exposure. Then what we did, we drilled down into these two, the ventilation and filtration aspects and the personal respiratory protective equipment, in other words, a mask. We drilled down into those and we asked a couple of questions. Are they cost effective and do they offer measurable health benefits? So then we took a deeper dive into that, and this is mainly what I'm going to be talking about today. Nico did a lot of the health impact assessment here and looked at if those two interventions actually had cost benefits that were positive, and I can tell you now that we did, otherwise I wouldn't forget. Okay, so let's quickly look at what we actually did. We assessed two different types of masks. You'll be familiar with surgical masks. If you were lucky enough to live in Tasmania during COVID, you would have met Gilbert. And Gilbert was the Labrador who was a service dog at Launceston Hospital. And Gilbert showed us how to wear a mask. He was very beautiful. He wears his mask perfectly, and then he uses it as a hat and so on and so forth. But we're all very familiar with surgical masks, and Gilbert's still around here in the States. And then P2 masks are N95 masks. They're the ones that are much more fitted. You can get them fitted. You can also just buy them from the chemist and squeeze them onto your face. And they tend to be a little bit more sealed. In general, they're going to have less airflow and be a tighter fit around your face. Then the two other types of interventions we looked at were personal air cleaners with HEPA filters. And again, there's two types of those. There's the branded ones that you can just buy in any big box shop, and then there's ones called do-it-yourself ones, which one is having a really good crack at in communities. These do-it-yourself ones are actually really popular in Canada and the US, and they're basically a box fan with some Nerve 13 filters around the outside that are taped on. And I'm sure John will have lots of experience with having community members try and put those together, but yeah. But they're much cheaper and they're just as effective as the more expensive big box brands. So these are our 4 interventions that we looked at. Now, I'm not going to go into this in a lot of detail, but this is the model that we produced to actually test whether there was a positive cost-benefit ratio at the other end. On the far side, we've got all the inputs that help us work out what some of the exposures would be. So we looked at hotspots, we looked at temperature to try and help us work out when wood heaters were being used. We looked at PM₂.₅. We looked at population, and so all of that went into that blue box there that was a population-weighted PM₂.₅ by capital city for a statistically representative year, and we had data that went from 2021 to 2020. So we were able to identify what days in that statistically representative year were being impacted by all those different types of biomass burning. In that green section in the middle, the model actually looked at all the things that went into our interventions. So how often was it used? How much did it cost? What was its reduction efficiency in terms of reducing the amount of PM2 exposure? We then did the health impact assessment, so all the costs of, I should say this is just mortality. So these are actually not including emergency department visits or not including ambulance call-outs, not including hospitalisations. This is just mortality. So all of those costs, and that spits out at the end a benefit cost ratio. So what happens? Now remember we did this in all the different capital cities. I probably can never say that. We did that in all the different capital cities. So where you live actually makes a huge difference. And we touched on this a little bit earlier. So what we've got here, and I appreciate this is quite tiny, but what we've got here on where I've got the red square is Canberra and Sydney. And so what you can see, this is the simulation population weighted daily PM₂.₅ exposure. So the blue line is the mean, and then we've got some confidence intervals or kind of our extremes in the grey bar. So it's really clear in Canberra and Sydney that what's driving PM₂.₅ is summer bushfires, yeah? We've got peaks at either end of those scales. If we look at Darwin, completely different story. So what's driving it in Darwin is the savanna burns that happen in the dry season, closer in the middle of the year. We look over here at Hobart, totally different story again. What we've got is some bushfires at either end, but then we've also got wood heaters in the middle of the year. So every city has a slightly different story. I just want to bring out Brisbane because obviously we're here. What do you think that represents? So we've actually got a much earlier bushfire season in this region than we do down south, and that comes up really clearly there. So we've got some burn-offs. Yeah, burn-offs, we've talked about this already, right? Burn-offs through spring and then some bushfires through summer. So probably no surprises there, but it's nice to actually put it all together. Now, because there's different results in all these different parts of the country, what we then did is that we assessed each of those capital cities with the health benefits. And what we found was all around the country, the health benefits outweigh the cost for all of our interventions. Unsurprisingly, surgical masks, so they're the ones that Gilbert was wearing, had the highest benefit cost ratio because they're very cheap. That was followed by P2 masks, followed by do-it-yourself portable air cleaners, and then followed by the branded portable air cleaners because that's the cost that's going up. So in terms of results, we can see that right across the board for every different intervention, so we've got masks, P2 and surgical, portable air cleaners, branded and homemade. Right across the board, we see that for all capital cities, for all interventions, there's a positive cost-benefit ratio. In other words, intervening makes a difference. So in conclusion, wherever you are in Australia, you need to use those interventions. Face masks have the higher cost-benefit ratio, but partly because their initial outlay and their operating costs are cheaper, and the results differ substantially across all of those capital cities. So they're the two papers. You can do the QR codes get away. Have I got time for questions?
Oh, yes. You have time for questions. I'm going to ask you the first one. I might have missed in your presentation because you did it nice and efficiently, but these are estimated reductions in exposure. They're not measured reductions in exposure.
Correct. So we're using previous studies that have said if you set up a HEPA filter in this environment, this is the reduction exposure.
Okay.
Yep.
Sorry, so the last slide before this was up quite quickly. So did that show that the surgical masks had no effect? Is that what the result was?
Sorry?
The surgical masks.
Small effect.
Yeah,
This
very
one,
small. Oh, sorry, the one above it. So that had a greater effect. So surgical masks, small effect. The P2 masks,
the surgical masks have a greater effect is because they're cheaper.
Yeah. Yeah.
Well, if I can offer a comment here, they are cheaper, but in terms of their efficiency for smoke,
Not as much.
basically not at all.
Yeah.
So, the problem here is that they are efficient. For example, if for community infection risk, they are more efficient, because those particles from human respiratory activities, these particles are bigger. So they're efficient. Now, particles from smoke, like for any combustion, are in the ultrafine size range. They follow the air, which means any. So that has been shown through studies, and therefore we shouldn't really recommend surgical masks as a protection against bushfire smoke. But the better mask, yes. But
sorry.
So there's one comment. So here it should be better masks should be, but in terms of filters, now during the pandemic, the terminology which has been included is you use HEPA. It's not even air cleaner, but use HEPA. The problem with this is that HEPA filters, indeed, they are the most efficient filters, but it comes at a cost, it comes at an energy, causes a noise. But numerous studies show that if you are using air cleaner, where air goes over and over again in no time at all, they reach the same effect as more efficient filters. So the community in this space is now recommending, we are not talking about HEPA filters, we are looking about efficient, like MER13 or something like this. This is really a comment, and this is not the point of all of this. But
and I can speak to both of your comments. So this is academic research in the sense that we shouldn't necessarily use this for policy. And so what you're saying is that, on the face of it, we should recommend surgical masks. And that's not what we're saying. We're saying that they're still efficient because they're cheap. But there are other methods which are also worth it. The second thing about HEPA filters, so what we factored into this model was a changeover of the filter itself. So I can't remember off the top of my head in the model, but it might have been every 6 months that the filter actually got changed. It might have been less, I can't remember. But changing over was also, the cost of that was included in the model. Yeah. So that goes partly towards what you're saying, that if you just stick a portable air cleaner with a HEPA filter and hope for the best, that's not really the best outcome. We still need to be changing those filters. Yeah.
Sharon, you've got the perfect opportunity to actually test all of this in the climate hut, and with some actual measurements of exposure with biomarkers, which we're going to be doing, aren't we, Faye? So is another hand? We've got one more question. Online, someone?
No. There's no.
No. Yes.
So what should you do if there's smoke in your house?
Go outside.
Smoke coming in from the outside.
Yeah, it's the question, isn't it? Right. So, during 2019, 2020, the public health advice was go inside, close doors, windows, and then we found, I think, as Ron pointed out earlier, that's not necessarily the best solution. It might be temporarily or short term, but it's not necessarily the best long term solution. And we're talking about 6 or 8 weeks of smoke. Right? So One of the things, you can still go outside, but you've got to make that inside safe. And so setting up a clean air shelter within your own home might be one thing that you could do. So that might look like setting up a bedroom, for example, having a portable air cleaner with a HEPA filter that's running in your bedroom, having the doors and windows sealed, and then you're getting 8 hours of respite from smoke while you sleep, which is fantastic. That reduces your overall load. But you can also pop back into your bedroom if it's particularly bad. If you need to leave, which you will eventually, because you need to go and get food or go and socialise, whatever, wear a mask.
I think we really need to examine the masks a bit better. Surgical masks were invented to stop surgeons dripping into the wounds that they were operating on. They were never to protect the person who was wearing it, and they don't. So thank you, Sharon. So our next presenter is Dr. Xuan Li from QUT. Apologies for getting the pronunciation not quite right. Who's going to talk to us about contributions of bushfire emissions to urban PM2.5 and ozone. And this is some of the work that Lydia was alluding to earlier in the day.
Good afternoon, everyone. I am Zijun, a research fellow working in the group led by Lydia and Sharon. And today, it's a pleasure to give my talk here. And the climate is becoming warmer, and there are more frequent and intense fire on the national landscape. And my talk I'm going to share today is within this context, with increasing bushfire. Is the air safe to breathe? I'm going to show you the work and then what is the contribution from bushfire emission to the urban air quality during the bushfire season in Queensland. Before that, I would like to acknowledge to the transition. So, as we know, climate is becoming warmer, and then the bushfire is becoming severe climate hazard, emitting a lot of air pollutant into the atmosphere. 5 particulate matter, NOx, CO, VOC, volatile organic compounds, of course, greenhouse gas, CO2, and methane. And on the right-hand side, you see a snapshot of severe burn in somewhere in Australia, and you also see the impact of that on the urban air quality in Brisbane. That's just a snapshot of a really severe burn. Again, if you open the satellite image, probably somewhere in Australia now there is a fire hotspot. And the question I want to answer with my work here is, regardless is severe or moderate, when they transport it to downwind to the urban area. So how do these bushfire emissions influence the urban air quality? So the study area we focus is in Queensland, and we collect the data. We download the data from the EPA urban air quality data site, and majority of them are in southeast Queensland, as you can see here, majority here, and there's some in Glasgow, some in another northern part funnel of Queensland. And the resolution of the data is hourly, and we focus on the time from 2008 to 2023. And the reason for that is back to that day, we start to have the MODI settlement. And of course, nowadays, you have the Himawari from the Japanese satellite. You start to get, every 10 minutes, you get the satellite image for the fire hotspot. And for the air pollutant we look at is 5 particulate matter, ozone, and MO2. And how we define the bushfire emission? We are not only talking about the severe burn, we are also talking about, in general, daily. If any bushfire transported, how does it influence the urban air quality? So we use the data from the bushfire hotspot, identify the MODI satellite. Sorry for the typo here, it should be the hourly PM2.5 levels. And we look at every 6 hours, and then we compare, and then we identify where are these bushfire hotspots. Not in today, but in the past 3 days, because the air masses we receive here is not only locally, but also transported from the outbreak to here. Quite often in atmospheric science, we look back to 72 hours or 3 days. Then we look at individual points for these 72 hours for that 6 hour window. Every 1 hour, every hour in this 6 hour window. And that means 72 times 6. And then at each hour, we compare with the bushfire spatially. If there are any fire hotspot intersected with our air masses, we count 1. If there's more, we count more. And of course, in my side, what if the fire is somewhere in North Queensland and just 1? And then what's the influence? Maybe not because the dilution effect. Or maybe there's many nearby, but they're just really small. What's the influence? So my method is statistically robust. So we compare with the PM₂.₅ concentration, as you can see on the right hand side. We try to find a perfect threshold. That means if the intersection is 1, and then we count all these masses are contaminated by bushfire, what's the correlation with the PM₂.₅ we receive at the site? And then we run with different threshold. We found within every 6 hours, as long as at least 17 intersection between the air masses and the fire hotspot, we claim that is impacted by the bushfire. So now we dive into the results. On the left-hand side, there's a 3 panel. The top panel tells you the monthly bushfire impacted hour within the past, within the 15 years study period. And the middle one, that is the mean fire-rated power of those identified power. Tells you how strong, how intense are those fire hotspots. And at the bottom, because we look at the air mass trajectory, we can identify where these hotspots from. So, as you can see from that, most of that are in fire season, highlighted in red, and there's some really teeny tiny in the non-fire season. And they becomes more frequent because we are seeing more impacted hours, and they have become more intensive because the mean fire rated power, you can see they become stronger. And most of them, but of the site we study here, most of them are from Queensland, highlighted in grey, but with time, in recent years, there are more these air masses, bushfire emission from New South Wales, highlighted in green here. So the next one is, I will talk about how I quantify the contribution from bushfire emission to the urban air quality. Let's imagine maybe there's bushfire emission somewhere and then transported to Brisbane now. We still have our daily activities. We still have our traffic, still have industrial, still have other kinds of human activities. So we need to account for that so that we know what is the net contribution from the bushfire emission. By to do that, I use a machine learning model. The principle is we use a machine learning model to train on the time not influenced by bushfire. We account for the local meteorology, air mass history, where they are from. We also account for the human activities. And by doing that, we can form a counterfactual model. That means we use that model, we form a what-if scenario. What if today we don't have bushfire? What should be the baseline? And after that, we compare with the observation value of bushfire day and our counterfactual baseline. And the differences that tells you the contribution from fire to the PM₂.₅ or the ozone. Let's look into some annual air quality summary during the fire season. And for the PM₂.₅, most of the time is the delta PM₂.₅ is stand for the contribution from bushfire emission to the PM₂.₅ received. So most of the time it's below 10 microgram per cubic meter, but for certain year it went about up to 20. And during this bushfire impacting time, And sometimes the contribution can be up to 50% for the air we breathe. And then we look into what is the story for ozone. You can see more or less the contribution from bushfire to ozone is more or less the same. Like let's say I would say around 10 to 15%. The reason for that is because PM₂.₅ is a primary emission from the bushfire. And for ozone, how ozone is formed is compressed. So the VOC, the reactive gas from the bushfire, when it passes the urban area, it interreacts with the NOx.
Really high level of me either keeping it in accumulation when on fire, taking it as a lump sum, or starting when it comes.
So just look into the summary how what's the characteristic of the data PM₂.₅. On the right hand side, the y-axis is the total fire radiated power, stands for the source, the strength of the fire, and on the bottom here is the prone age, that means how far from the hotspot. As you can see, if the prone age is higher, the PM₂.₅ is lower than because the dilution effect. If you go to the y-axis, go up, that means the fire is stronger. The impact for the PM₂.₅ we receive is more severe. And as I said, the story for NOx is quite complex, and I use a marker here to indicate the ratio between the delta PM₂.₅ standing for the strength, the emission strength, the influence of the emission we receive, and the MO2 is a marker for traffic. So if the ratio is, based on the study here, if the ratio is less than 0.5, the delta ozone is below 0. That means the ozone formation is suppressed by the bushfire emission. If it's about this ratio is about 0, that means enhanced. There's two regimes. One is not saturated regime. Another one is the VOC saturated regime. That is I want to share today. And then, thank you. If you want to know more, you can look at our
Can I ask you just a little bit more about the ozone?
Yes.
Surface level ozone, which is what we're talking about, requires sunlight to form it, and I guess that's why you've got an axis where it's suppressed by the smoke. There's no sunlight, but the quality or the type of VOCs is also probably important. What can you tell us about that? Because the VOCs from bushfire will be different from the VOCs from traffic and from the city on a non-bushfire day.
So first, for your question is, you say the solar radiation can be reduced. Yes, that depends on how severe, how high is the PM₂.₅ concentration. We saw that under certain conditions. If the PM₂.₅ is really high, it blocks certain of the sunlight is suppressed. Yes, it's true. And for the difference, and for the second question, for the VOC type, we don't have the measurement. It will be great at some real-time measurement. But what I learned from the literature is for the traffic, you have this benzene, toluene, this aromatic compound, and then from the biomass burning, you have this phenolic compound. But of course, you have many types of components. A pH,
Great presentation, and it's an interesting work. So my question is about the satellite imageries that you're using. So Himawari and Modi. So they have like different spatial resolutions, and like some bands are around like GSD is around 2 kilometers. So because you are using transport models to model how the fumes would take from the source to the other locations, I'm just wondering how would that spatial resolution would have impacted the results that you're getting. Thank you.
So first is about the satellite. Depends on what satellite used. If Himawari, that is a different story, and because it's how high the Himawari operated, and you can run that one for the Himawari, but I think eventually you need to calculate how many data. And for the spatial resolution, for us is I can't remember it's 0.5 or 1 degree. But we also run the analysis with the radiating power, not only the PM₂.₅. We also get the local maximum at where we have this threshold. So it's statistically robust. What is not accounted for, you can say, is we look at the spatial and how what is the injection hub. That is something we don't look into, but with this such big data, I don't think the conclusion will be that out. Okay?
Yeah, great talk. There's studies showing that nitric oxides are one of the leading modifiable factors involved in dementia, and you are looking at nitric oxides, but can you tell the difference between what is contributing from traffic and industry compared to bushfire smoke?
I can't really say that because I don't have evidence, but I'm doing the work because my model can separate what is from the PM₂.₅ from traffic, what is from the bushfire, and we are doing epidemiology analysis, and then we try to account for that. And it's different from general what people doing because they take the total PM₂.₅, but now I can separate. Yeah, good to have more discussion with you because you're expert in that.
One thing you might look at is the metal content of the PM, because that can tell you the difference whether it's come from fossil fuel or organics.
Yeah.
Other questions? Okay, thank you very much.